Let's talk about how to graph a circle that's been written in general form instead of standard form. In order to handle problems like this, you're going to have to remember some of your algebra skills from last year. So let's do a quick review of factoring. Remember that to factor an expression, you figure out the factors of c, which is the last number, that add up to b, which is the middle number. Factors are things that multiply together to get to that number, so for 9 it's 1 and 9, or 3 and 3. And the pair that would add up to 6 would be 3. So you can write x plus 3 times x plus 3, or you could just say x plus 3 squared because they're the same binomial. Let's try another one. What are the factors of 5 that add up to 6? Well, there's only one pair of factors of 5, 1 and 5, and 1 plus 5 is 6, so it's x plus 1 times x plus 5. What about 4? What are the factors of 4 that add up to 6? Well, there's two pairs of factors of 4. We have 1 and 4, and we have 2 and 2. But neither of those factors add up to 6. 1 plus 4 is 5, and 2 plus 2 is 4. Neither of those answers were 6, so what am I supposed to do? There aren't any factors of c that add up to b. Well, we have to do something called completing the square. You may or may not have learned how to complete the square last year, so let's do a quick review, or learn how to complete the square. This process relies on something called perfect square trinomials, which is something like the first warm-up problem that we looked at. Since both of the binomials were the same, it's considered a perfect square trinomial, that 9 square rooted was 3, and 3 plus 3 is 6. The formulas, depending on if it's a positive or a negative, are basically the same thing, just with a difference in the signs. That if you have an expression that looks like this one, you can factor it into this form. In other words, if you square root this number, and it's equal to double that number, then it must be a perfect square trinomial. So the square root of 25 is 5, and the double of 5 is 10, so this is a perfect square trinomial, which means I can factor it into just x plus 5 squared. And it's the same idea if you have a negative instead. The square root of 4 is 2, and double of 2 is 4, so this is a perfect square trinomial. Since it's a minus, I'll factor it into x minus 2 squared. But what if I didn't tell you a complete perfect square trinomial? What if I just told you that the first term was x squared, of course, and I told you the middle term, but I didn't tell you what we were adding to it at the end? I didn't tell you c, or in this case we'll call it n. How could you figure out what this number would have to be in order to make it a perfect square trinomial? Well, you might be stumped, so let me give you a hint. Let me go ahead and tell you what n is for each of these, and you tell me why it is what it is. What's the relationship between n and this number? For all of these, what you do is you divide by 2 and then square the answer. So 8 divided by 2 is 4, 4 squared is 16. 14 divided by 2 is 7, 7 squared is 49. 12 divided by 2 is 6, and 6 squared is 36. So for our problems today, we're going to need to complete the square, which means you'll have to be able to figure out what n is. To figure out n, you take b, divide it by 2, and square it. So let's try an example. We're going to complete the square in order to solve this equation. In order to do that, we have to start by moving the 3 over to the right-hand side of the equation. I want the x squared and the 10x to be alone because what we started with was not a perfect square trinomial. We're going to make a perfect square trinomial using the x squared plus 10x. So I'll move the 3 over to the other side, and then I need to figure out what would I add to x squared plus 10x to make it a perfect square trinomial. What's n? And to do that, I divide by 2, and I square. So 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 to both sides, because that makes it balanced. What I do to one side, I have to do to the other. So if I want to add 25 to my x squared plus 10x in order to make this a perfect square trinomial, then I would also have to add 25 to the other side to keep it balanced. So since this is a perfect square trinomial, I know I can factor it into x plus 5 squared. And then 3 plus 25 is 28. Now in Algebra 1, you learned how to go further than that and actually get an answer for what x is, and we don't need to do these last two steps for what we're doing today. We just need to do the perfect square trinomials part to end up with something that looks like this, the x plus something squared. So let's try another one to make sure we know what we're doing. we're going to complete the square for this equation. So the first thing I need to do is move the 35 to the other side. And then I need to decide what do I add to x squared minus 6x to make it a perfect square trinomial. To figure out that number, you divide by 2 and you square it. So I get 9. So I'll add 9 to both sides. And that means that this can be factored into x minus 3 squared. And 35 plus 9 is 44. So for today, that's as far as we'll go. In algebra, you would keep going to figure out the actual answer. So how on earth does this apply to what we're doing with graphing equations of circles? We learned how to graph from standard form in our previous video, that h and k was the coordinates of the center and r was the length of the radius. But not all equations of circles will be written in this form. This is called standard form, but sometimes you'll have equations of circles written in general form. General form comes in 2 different forms depending on what you're looking for. Sometimes it's ax and by, sometimes it's 2fx and 2gy. But either way that it ends up being written, it's not easy to identify the length of the radius or the coordinates of the center. So in order to graph from this form, you're going to have to convert it to standard form first. You might be wondering how on earth did we even get this form? And you can actually find it by going the other direction, by going from standard form, which is what we already knew. You'll start by expanding, in other words, multiplying x minus h times x minus h, which gives you x squared minus 2hx plus h squared, and multiplying y minus k times y minus k, which gives you y squared minus 2kx plus k squared. Then rearrange to group like things together, and do some renaming. We're going to call h negative f and k negative g. That way these two terms end up as positives. And we're going to call h squared plus k squared minus r squared. Those are all of our constants, so we're going to group that together and just call it c. And sometimes they rename things even further, and instead of 2f, we call it capital A, and instead of 2g, we call it capital B. But to go the other direction, to go from the bottom of the screen to the top of the screen, you're going to have to complete the square. And you're actually going to have to do it twice, once for the x terms and once for the y terms. So to get started, you're going to rearrange your variables so that like terms are together, then complete the square, and combine like terms, and you'll have a standard form equation that you can graph from. Let's take a look. So here we have a general form equation, and we need to rewrite it to be in standard form. So the first thing I'm going to do is rearrange my terms so that the x's are together. So I have x squared minus 6x. And the y terms are together. So I have y squared plus 14y. And I went ahead and moved c over to the other side, so everything equals 6. So now I'm going to complete the square twice. Once for x squared minus 6x, and once for y squared plus 14y. So I need to figure out what do I add inside of these parentheses to make this a perfect square trinomial. Well, I divide by 2 and square it, so 6 divided by 2 is 3, 3 squared is 9. So I'll add 9 inside of these parentheses. And I'll do the same thing for my y's. If I divide by 2 and square, I get 49. So I'm going to add 9 in the first parentheses to make this a perfect square trinomial. And I'll add a 49 inside of these parentheses to make this a perfect square trinomial. But if I add 9 and 49 on this side of the equation, I must also add 9 and 49 on the other side of the equation. Now I can factor each of these into x minus 3 squared and y plus 7 squared using the perfect square trinomials formula, and combine these like terms and get an answer of 64. Let's try another one like that. Again, the first thing to do is rearrange so your x's are together, your y's are together, and the constant is on the opposite side. Then complete the square, making sure that whatever you add inside of each of these pairs of parentheses, you also add on the other side of the equation to keep it balanced. Then factor and combine like terms, and this is your equation. So now that you have that equation, you're ready to graph. The center would be the point -6, +5, and the radius would be 4 units long. So put a point at -6, +5, and count up 4, right 4, left 4, and down 4, and draw your circle. Let's try another one. First step, rearrange. Second step, complete the square. And final step is to factor and combine like terms. So now that you have your equation, you can identify the coordinates of the center and the length of the radius and graph. I want you to try the last example on your own. rewrite this general form equation to be in standard form, then identify the length of the radius and the coordinates of the center, and graph the circle. Pause the video and try it now. Let's see how you did. First thing we do is rearrange. Then we complete the square. Then we factor and combine like terms. So it turns out that the center of this circle is the point -2, -9, and the length of the radius is just 1, so it's a teeny tiny little baby circle down here at -2, -9, with a radius of 1. And that's all you need to know about how to graph a circle in the coordinate plane. In our next lesson, we're going to learn how to calculate the length of an arc and the area of a sector.